Hello friends, I'm Rohit. In this video, I will be discussing about the circuit diagram of single phase induction motor, also its connections. To get the practical ideas, watch my previous video. I will also provide the link in the description below. This topic was requested by one of my viewer, so I hope you are watching this video. So let's get started. Well, for the operation of induction motor, a rotating magnetic field is required. And this rotating magnetic field can be introduced by generating two alternating current. Is it clear? Then question arises, how to generate two alternating current? Well, two alternating currents can be initiated with the help of this arrangements. This whole arrangement is present inside the single phase induction motor. Okay, so let's decode this arrangement. Well, there is a main winding and there is an auxiliary winding with a capacitor connected in series with the auxiliary winding. Well, the capacitor draws leading current from the source, and this winding, the main winding, which is basically an inductor, it draws a lagging current. Here is also inductor, but though as there is a capacitor, it draws a leading current. So what happens here? This circuit draws leading current and this circuit draws lagging current, okay, creating two alternating currents with a phase difference. Okay, is it clear? These two alternating current basically provides a resultant current. Okay, these two alternating currents provide a resultant current that is of rotating in nature. Very simple. Done. The topic is over. That rotating magnetic that current which rotates, that creates a rotating magnetic flux. So that rotates the rotor. That is the whole concept behind it. I hope it is clear to you all. So what I will do now, I will just implement this idea in the phasor diagram. So I have taken a reference as a voltage, means the voltage I have taken the reference. Okay, so this main winding is of lagging in nature, so I have shown here this is the main winding, and the auxiliary winding is of leading nature, so I have shown here. So its resultant is I, that is of rotating type. This current, the resultant current, will produce a rotating magnetic field that will rotate the rotor. This was the whole concept. Okay, so now let's see the connections. So this live wire is connected with one end of the main winding and also one end of the auxiliary winding. The other end of the auxiliary winding is connected with one end of the capacitor, and the other end of the capacitor is connected to the neutral, and this neutral is also connected to the other end of the main winding. Means the simple funda here is the capacitor is connected in series with the auxiliary winding to create a phase difference of 90 degree, approximately 90 degree. Capacitor, the pure capacitor, draws 90 degree leading current. Okay, means leading current at 90 degree, but here it is not a pure capacitor, so approximately it will draw leading current with an angle of 80 degree, which I have shown here. Okay, so see if it would be 90 degree, then this resultant would be in phase with the voltage. So as it is 80 degree, so it is just shifted with an angle phi. Okay, so it is the whole concept. This was the whole concept. Okay, this is the whole funda behind it. So I hope it is clear to all, and if the video was interesting, then don't forget to like, share and subscribe, and stay tuned with me. Have a nice day. Thank you.